This demo is going to be about one-way repeated measures ANOVA using the same example we talked about in our lab. 20 men who are consuming different amounts of quantities of beer on different nights, and we are measuring how many women they're oogling for each condition. So in order for us to compare whether this data is different across different conditions, we will be running a one-way repeated measures ANOVA. Now before we actually run the analysis, we need to figure out what kind of contrast we're running. Since I don't see that we have a baseline condition unless stated in our hypotheses, I think a repeated contrast makes sense. So with a repeated contrast, we will compare condition 1 to condition 2, condition 2 to 3, and condition 3 with 4. Okay, so let's run the analysis. We'll go to Analyze, General Linear Model, and Repeated Measures. Here we are going to add within subject factor name, we can just call it pint. And I know we have 4 levels, so we're just going to enter that information. Next, we are going to hit define. And here we are just going to add all of these variables into the next box. So kind of like SPSS note that 1 is pint 1, 2 is pint 2, and so on and so forth. You're not going to look to select anything from the model menu. For the contrast though, we have to specify what kind of contrast we're running. Since we are interested in repeated contrast, that's what we're going to select, and make sure you hit the change button. Continue. For plots, we are not interested because it's just one variable IV we have. If we had more than one, we would look at the plots as well. For the post hoc, we are not interested in this one either because this only applies if you have a between subjects factor. For the options, we are going to be interested in just in the means for those variables. We also click descriptive statistics, effect sizes, transformation of matrix. So basically it's going to give you that table with 1s and 0s for contrast codes. And we are also running main effects, and we're doing a bond-forming connection. Continue, and we are going to hit OK. So this basically gives you a bunch of tables again. Overall, you can see that we're looking at the coding we gave SPSS. We're looking at the descriptive statistics. If you look at the means themselves, we see that when someone is drinking 1 pint of beer versus 2, there's not much of a difference there, but there's a little bit of a jump from 2 to 3, and then it's not that much of a difference from 3 to 4. So just an overview of what the data looks like. If you look at the Mockley's test of severity, we see that it is significant. So that is the case which shows that the variance between different levels is significantly different. So in that case, we are going to use a correction, either greenhouse geyser or Hanfield. For our lab, as I told you, most of the time we will be using greenhouse geyser, but if you're interested in like more detailed information about when to use when, you can look at the lab notes or read the book. But for this example, we are going to use the greenhouse geyser correction. So if that happens, Mockley's test comes out to be significant, then when you're reading the table, you're looking at the row that says greenhouse geyser, and we're not looking at the severity assumed. So greenhouse geyser row basically adjusts for the degrees of freedom. We're not going to get into how we're adjusting for that. You can take a look at the book for that information. So all in all, we're basically looking at this row. So looking at the significance level, we find that it is significant. So it is when we are comparing different levels, there is some significant difference between different contrasts we ran. Now, this is not telling us exactly where that difference lies, so we will have to further investigate. we will have to look at the test stuff within subject contrast table. And here it is showing us all the comparisons that we pre-planned. So since this was a repeated contrast, so we're comparing pint 1 with pint 2 with pint 3, and pint 3 with pint 4. So if you look at the significance levels of all of these, we find the only contrast that is significant is between level 2 and 3, which means that if someone is drinking up to 2 pints of beer, it doesn't really make difference in terms of how many women they're looking at. But if they drink more than that, especially when they go from 2 to 3 pints, there will be a significant difference in the number of women they're looking at. And if you remember, when we looked at the means here, they kind of gave us the similar trend here as well. So kind of like speaking to that. One thing you can do when you're reading these tables, sometimes, when I'm looking at it, I forget which one was level 1, 2, or 3. In this example, it's kind of easy to remember because we're talking about pint 1, 2, and 3, and 4. But if it's something else, sometimes I get confused about it. So you can potentially go in the table itself and change that information. So if I double click on this, and I can change this information. So level 1 versus level 2 was pint 1 versus pint 2. I can write that here. I can do pint 2 versus pint 3. Pint 3 versus pint 4. So this basically changes everything in all the rows for that table, and it makes it easier for me to compare. All right. And if you go a little bit down, there are a lot of tables that we won't be looking at, but a few that I want to show you. So one of them is this one, which is transformation coefficient matrix, which is basically giving you that table which you were used to making when figuring out which contrast to run. So basically this is giving you don't have to do it by hand. If you look at the pairwise comparisons table, this is the post hoc analysis of all the other comparisons and all of the possible comparisons there can be within the all the possible comparisons there can be for different levels. So for example, we never ran how pint 1 compares to pint 3, but this is the comparison that we can look at here. We never compared pint 1 with pint 4, but you can look at that information here. Now, typically when you're running one-way repeated measures ANOVA, or any kind of ANOVA, you're not running planned contrast and post hoc contrast at the same time, but I'm just showing you that for the sake of teaching you. And when you're writing your analysis, writing your APA style interpretation, unless asked to write a post hoc comparison and talk about it, you will just skip that. And here too, you can change things so it's easy for you to remember. Pint 2, pint 1, enter, pint 2, and same goes for here. So this is, I'm just showing you that you can change these things. And this will come in very handy when you are doing other contrasts. Okay. All right, so this basically tells you how to run one-way repeated measures ANOVA and what are we looking at from all the tables that SPSS gives you. So I hope this is helpful for how to write an APA style interpretation. Please look at the guide provided in my lab notes, and hope this is helpful. Thank you.